Yo, 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 yo! Welcome. We are doing Math Quest 2012, Math B, Chapter 8, reviewed. Question 9, continuing from the previous videos. Alright, is another multiple choice question. Okay, the area bounded by the curve on the graph at right and the x-axis. Okay, so it's between the curve, the area bounded by the curve, and the x-axis. Right, is equal to, well, we're supposed to find out. This question, there's two sections, right? This particular section 1, and that's particular section 2. Now we should do it. We should do each section separately, because in each of the section, what is our method top minus bottom, that equation can change, right? Because at section 1, our curve y function is on top, where our x-axis is on the bottom, is at the bottom. But in the second section, the x-axis is on top and the y function is at the bottom. So we should do it separately. Okay. So we go to section 1. Integrate. Oh, so we need to find the x-intercept as well. All right. So we need to find out this point, and this point. They are all the x-intercept. Okay, so that should be first. To find x-intercept, sub y equal to 0. So the function becomes, therefore, 0 equal to x plus 2, or x minus 3. Right, when we have 0 on one side and the other side is all multiplication, it's all multiplication, we can use the Null Factor Law. The Null Factor Law. Now, what the Null Factor Law means is just that if something times something times something, or it's just, let's just say it's simple, let's say if something times something give you 0, or if A times B give you 0, either A is 0 or B is 0, right? So we got A, B, C here, A, B, C here, and they times each other to give you 0. So either A is equal to 0, or B is equal to 0, or C is equal to 0, right? So we do it for each one. So x is equal to 0, or x plus 2 is equal to 0, therefore x is equal to negative 2, or x minus 3 equal to 0, that means x is equal to 3. So these three x coordinates are our x-intercepts. So let's go up there. So this one must have a coordinate of 3, 0. This one must have a coordinate of 0, 0. And this one must have a coordinate of negative 2, 0. So there you go. We found all our x-intercepts. Alright, then we can use it as a domain. So we're integrating in section 1, that is from negative 2 to 0. Right? And top minus bottom. Integrate with respect to x. Equal to, top is that function. Right? And then minus the bottom function, which is the x-axis, which is the 0. Alright, now what can we do here is we can expand, we can distribute, expand all the brackets. Alright, so it becomes x squared plus 2x multiplied by x minus 3. So what I did, just distribute this into this one. Alright, the negative 0 is gone. Alright, next we expand the next bracket. Become x cubed plus, or minus actually, minus 3x squared plus 2x squared minus 6x. Integrate with respect to x. Alright, tidy it up a bit more. So that gives us x cubed minus x squared minus 6x. Now we can integrate. Alright, so x cubed become x to the power of 4 over 4 minus x to the power of 3 over 3 minus 6x squared over 2. From negative 2 to 0, and that would just mean minus 3x squared. Right? And then, because the 6 and 2 cancels, if, you know, he didn't realize it. Okay. Alright, let's sub the numbers in. Alright, so it's, the first one just all zeros. Fun stuff. Very difficult. I don't know what the answer would be. It's almost gonna be like boom, boom, boom. Honestly, I should start charging a certain K-pop singer group for advertisement fees now. Alright. Oh no, not negative. So we get negative to the power of 4 over 4 minus negative to the power of 3 over 3 minus 3 times negative 2 squared. Right? We get, so the front bit is 0, so I wouldn't write it down anymore. So we're focusing on the second bracket. Remember this negative sign, very important. So this would be negative 2 to the power of 4 is 16, positive 16, 16 divided by 4 is 4. Minus negative 2 to the power of 3 is negative 8. So negative become positive. 8 over 3. And negative 3 times negative 2 squared. Negative 2 squared is 4. Negative 3 times 4 is 12. So what do we get inside the bracket? We get 4 plus 8 over 3 minus 12. We get negative 5 and 1/3. And because of the negative sign outside of the bracket, this will becomes a positive 5 and 1/3 unit square. And that's our section 1 area. Right? Let's head on to the section 2 area now. Section 2, I believe we remember now, we're done with this bit now. We're done with this bit. And now it's this bit. From here to here. So from 0 to 3. Alright, from 0 to 3. And then top minus bottom. Integrate with respect to x. That will give us top function. Remember, the top function in section 2 is the x-axis. Alright, it's this x-axis. This is the top bit. This is the bottom bit in the section 2. Alright, so it would be 0 minus whatever that y function is. Now, we already found out what that is before. So if we expand all the brackets in the y function, we get x cubed minus x squared minus 6x, right? So there's no need to do that again. So we just put that one in. So x cubed minus x squared, is it x cubed? Yep, minus 6x. Integrate with respect to x. Alright, expand the bracket. Become negative x squared cubed plus x squared plus 6x. Integrating with respect to x. Alright, let's start integrating. Well, we already know from previously, we already know what it becomes, right? So, but just remember, some of the negative and positive might change, so you can't copy the before. Like you can't copy the operation, the plus and minus from before, but you can copy what the integral is. The integral doesn't change. So this one, positive x cubed over 3, positive 3x squared. Yeah? From 0 to 3. Easy. Okay, let's sub the numbers in. So, negative 3 to the power of 4 over 4 plus 3 to the power of 3 over 3 plus 3 times 3 to the power of 2. Minus, now the next bit just become all zeros, but for communication's sakes, let's write it out. No, easy communication mark. Why not? Why not get it? Okay, then boom, boom, boom. Alright, so let's focus on the fun bit. 3 to the power of 4 is 81 on 4 plus 3 to the power of 3 divided by 3 is that just means 3 to the power of 2, that is 9 pluses 3 times 3 to the power of 3 squared, that means it's 3 times, that just means 3 to the power of 3, which is 27. Oh, this is negative sign here, so don't forget about that. So that's all we got. So let's do that. Negative 81 over 4 plus 9 plus 27 give you 15, positive 15 and 3/4 units square. And this is the section 2 area. Therefore, total area is equal to what we got before, 5 1/3 plus 15 3/4. Alright, plus 5 1/3. We get 21 and 1/12 unit square. That's it. That's the final answer. Final answer. Feels like, you know, who wants to be a millionaire? Do we have it? Yeah, we got it. B. And there we go. That's our answer. Alright, that's question 9. Alright, let's move on to question 10. Alright, it looks like question 10 to 12 is all in the same lot. Okay, so let's go one by one. Alright, the graph of f of x is, apply to the curve of the equation. Okay, so the equation is this, equal e to the power of x minus 1. The graph of f of x is best represented by, so well, we have to just to do this, you can grab it in the calculator and see which one it is. But to be honest, all you need to do is just know, okay, what sort of graph do we have? We got an exponential graph with a constant negative 1. Alright? So where would it be on the what would be the x-intercept be? So let's say x-intercept, right? 0 is equal to e to the x-intercept, y equal to 0. Okay. No, let's find a y-intercept. That's better. Hey, mind you, the x-intercept still works, but you know, it's just easier to find a y-intercept. Y-intercept. So when x equal to 0. Now, e to the power of 0 is 1. Anything to the power of 0 is just 1. So y equal to 1 minus 1, y equal to 0. So which one have a y equal to 0 intercept? So we've got 1 here, and we've got 1 here. Right? Oh, and this one as well. But we know this one is not exponential increase, so boop boop, you're not the right answer. Okay, so these two. The difference between these two is one's got an asymptote at negative 1. So does it mean this value can't be negative 1? Let's give it a try. Negative 1 equal to e to the power of x minus 1. And 0 become e to the power of x. Can we log 0? Can we ln 0? Nope, we get a math error. So that we do have an asymptote at negative 1, so that would be our right answer. Yeah, so that's how you look at the graph and determine something, which graph it is. First, you have to know the nature of the graph. At least you have to know what it looks like, right? When you see an exponential function or or the Euler's equation, they call it, you know it's going to increase exponentially, right? And and it's going from positive to infinity. It's never going to be negative in value. So you can't, because you can't log, you can't e to the power of you can e to the power of negative, but you can't log ln to the power of negative. So all these ones wouldn't work. And then look at the x-intercepts or y-intercepts that you could, and then you should be able to deduce which particular graph it is. Alright, question 11. The area bounded by the graph of f of x, which is our Euler's equation, ex minus 1, and the graph of the f of x, the x-intercept, the x-axis, and the line x equal to 2. The area bounded by the graph of f of x, the x-axis, and the line x equal to 2. Oh, okay. So we are literally just finding, let's just use this graph as example. If this is 2, right, so we're just finding here. Alright, from 0 to 2. So integrate from 0 to 2, ex minus 1. Oh, sorry, no, we do it the old way. The old-fashioned way, top minus bottom. Always do it this way. Now, which one's at the top? I believe our Euler's function is on the top, so it will be ex minus 1 minus whatever is on the bottom, which is 0, the y at the x-axis. Yeah? And this is ex minus 1. Alright, and now let's integrate. When you integrate ex, this doesn't change, the ex itself doesn't change. You divide it by the derivative of this, which is 1. Minus x. From 0 to 2. Alright, so now we can set the numbers in. This is e to the power of 2 minus 2 minus e to the power of 0 minus 0. Alright. Now remember, e to the power of 0 is not 0. E to the power of 0 is 1. 1 minus 0 is 1. So it becomes negative 1 here. So we got e minus 2, e to the power of 2 minus 1. So that is just e minus 3. E to the power of e squared minus 3. Alright. So do we have that? Oh, we got it on E. Question E, answer E. There we go. Alright, so that's question 10 and 11. Alright, let me copy down 12 as well. Alright, question 12. Look, remember, because it's still related to that particular function, alright? Ex minus 1. Okay. The area bounded by the graph of f of x. Just to let ourselves know. That is just ex minus 1. The y-axis. Ooh, this time it's the y-axis. Tricky. And the line y equal to x minus 1 is equal to. Alright, so we need some visuals here. Alright, let's go to decimals. Alright, here's the graph. Now we look this time, we're not looking at the x area. We're not looking for area between the equation and the x-axis. Now instead we are looking for, remember, we are looking for the area bounded by the graph of the function, the y-axis, and the line y equal to x squared minus 1. So we are actually looking for these areas, right? From here to here. All the way down here. I might change the look of the graph because, I might shrink it a bit or stretch it a bit. So, alright, so we're looking for that particular area. Alright, so now we can still do it. We're still finding area between two curves, right? Between that line, this is the top line now, and this is our bottom, right? And it is from 0, remember, 0 to this particular point, correct? So all we have to do is just find out that particular point. Alright, now at that particular point, at this particular point, our equation y equal to ex minus 1 is equal to e squared minus 1. Right? So if we do that, so that means e squared minus 1 is equal to ex minus 1. Right? Let's just move the minus 1. E squared is equal to ex. Then obviously, x is equal to 2. Right? Makes sense? I hope it makes sense. So this is 6.389, or you can write it as e squared minus 1. Alright, so that's our coordinate. Alright, and let's start solving the equation. So we're solving for from 0 to 2. Right? From 0 to 2. The top equation minus the bottom. Integrating with respect to x. Alright, so that's equal to, remember the top function is e squared minus 1. Right, that's what the top function is, y equal to e squared minus 1. Minus our bottom function, which is ex minus 1. Integrated with respect to x. Alright, let's expand the brackets. E squared minus 1 minus ex plus 1. Right? Integrate with respect to x. And now the minus 1 and plus 1 is just cancel out, leaving us with e squared minus ex. Okay? Integrate with respect to x. Alright, let's start integrating. Now, when you integrate e to the square, you don't do this. No, because there's no x in e squared. E squared is a constant. E is Euler's number, 2.718, blah, blah, blah. So e squared is just mean 2.718, blah, 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 or square. So that is a number, it's a constant. So when you integrate a constant with respect to x, you get e squared multiplied by x. That's it, that's so simple. Minus, now you need to divide it by the derivative of this thing. Okay? And that's it, from 0 to 2. We can set the numbers in for now, from now on. So it will be 2e2, right? I'm just writing it, swapping the places a bit. So 2e squared minus e to the power of 2, right? Oops. Minus e squared multiplied by 0, right? Minus e to the 0. We get, now 2e squared minus 1e squared just give you 1e squared left, right? And what we got inside, e squared times 10 is 0. So e squared times 0 is 0. Negative minus, now e to the power of 0 is 1. So this is negative 1 in there. And that just gives us e squared plus 1. And that is right there. That's it. That's our answer. Looks a bit tricky, but if you look at it carefully, it's not that hard. Alright, it's around 20 minutes, 20 something minutes now. Okay, and let's head into a commercial break. And we'll come back with question 13 and onward.